Hey, welcome. Today, we're diving into the really clever algorithm that takes a generic, one-size-fits-all ranking and turns it into a personal recommendation. You know, the magic that makes it feel like a suggestion was made just for you?
Okay, so we all know PageRank, right? It was this big idea that gave every single page on the web one global score. But that seems so generic. I mean, how can one score for absolutely everything possibly know what I find interesting?
That is the perfect question. And to really answer it, we've got to rewind a little bit and first get a really solid grip on how that standard, generic PageRank actually works. So let's get into it.
At its heart, PageRank isn't just about websites. It's a way to measure influence or authority for pretty much anything that you can map out as a network, what we call a graph. So think social networks, product recommendations, or even scientific papers citing each other. It really all just comes down to the connections.
The best way to wrap your head around this algorithm is with a really simple idea. Just picture an imaginary surfer kind of randomly wandering through the network. The whole logic of PageRank is built around the path this imaginary person would take.
So, our standard surfer kicks things off on a random page and just follows a few links. But then, and this is the most important part, they get bored and they jump to a completely different page, anywhere in the entire network, totally at random. A page's rank is just a measure of how often our surfer lands there over time. The pages that get the most visits, they end up being the most important ones for everyone.
Right, okay, I think I'm getting it. It's basically a global popularity contest. The pages that everybody links to become the big hits, kind of like a worldwide bestseller list. But that still doesn't solve my problem, does it? That list is the same for everybody. It doesn't tell me what I might like based on my own specific tastes.
Exactly. You've just hit on the exact limitation that led to this really brilliant adaptation we call Personalized PageRank. It takes that global bestseller idea and customizes it for an individual's point of view.
And here is the truly cool part. You don't need a whole new, super complicated algorithm. The solution is just brilliantly simple. You just change one tiny thing about our surfers' behavior, and that's where they jump when they get bored. To do that, we have to introduce a new idea, the source vertex. Think of this as your home base in the network. It could be your profile on a social media site, a product you just bought, or maybe a paper you're researching. It's the anchor that makes the personalization possible.
Okay, so let's check in on our surfer's journey again. The first few steps are exactly the same. They start on a page, they click around, but now, when they get bored, they don't jump to some random page anymore. Instead, they always, and I mean always, jump right back to your specific source vertex.
And that one little change is the whole game. In standard PageRank, that random jump creates a global rank. But with personalized PageRank, that targeted jump back to a single source changes everything. The ranking isn't about what's important to the whole world anymore. It's about what's important relative to your starting point.
Okay, the theory is definitely clicking now. That one small change seems incredibly powerful, but I'd love to see how it actually works. Can you show me a real example of this in action?
Absolutely. And the source material for this explainer gives us a perfect demonstration using a real-world network of scientific papers. In this graph, each paper is a node, and a citation from one paper to another acts as a link.
So, using standard PageRank, one of the most influential papers in this entire network is titled Non-Compact Symmetries in String Theory. We're going to set this paper as our source vertex, our anchor point for this whole personalization exercise.
So the question becomes, if our imaginary surfer is constantly teleporting back to non-compact symmetries in string theory, what other papers are they going to end up visiting the most? What does the network look like from the point of view of this one single important paper? And the algorithm gives us this. The top-ranked paper from that specific viewpoint is an algorithm to generate classical solutions for string-effective action. Now, this might not be the top paper globally, but it is highly relevant and related to our starting point. The algorithm successfully found a specific contextual recommendation. It worked.
That is a fascinating result. But let's zoom out a bit. What's the bigger picture here? Why is this small algorithmic change so important in the real world?
Well, this simple change is what lets us escape that one-size-fits-all world. By creating these user-centered ranks, it becomes the engine behind features we use every single day, like people you may know on a social network. It's just proof that sometimes the smallest change to an algorithm's rules can have the biggest impact.
Ultimately, personalized PageRank really shows us that by changing just one rule, where an imaginary surfer jumps, we can completely transform a tool for measuring global popularity into a powerful engine for creating truly personal, relevant experiences.
It really gets you thinking, doesn't it? If almost any system of ranking can be personalized this way, what's the next game-changing recommendation you're hoping to see?
If this explainer helped you connect the dots, be sure to like, share, and subscribe for more. Thanks for watching.